Assalamu alaikum. This is 12th chemistry, and our today's lecture is the chemical properties of these amines. As we have discussed some of the chemical properties in our this previous lecture, and now today we are going to continue the same. That is the chemical properties of these amines. Now, as far as these chemical today's lecture is concerned, first of all, we will take the reaction of these amines with this nitrous acid. Now, as far as this nitrous acid is concerned, this nitrous acid is unstable and is therefore it is freshly prepared by treating this sodium nitrite with ice cooled this dilute HCl or sulfuric acid. This is you can see here, this is sodium nitrite. When it is made to react with this HCl, it forms this is nitrous acid plus NaCl. Now, as far as these amines are concerned, different classes of these amines, like we have primary, secondary, and tertiary, they react differently with this nitrous acid, and so this is used as a test for distinguishing primary, secondary, and tertiary amines. Now, as far as these primary amines are concerned, these primary aliphatic amines, they react rapidly with this nitrous acid to give rise to the formation of alcohol with the evolution of hydrogen gas. Now, you can see here, this is ethyl amine. When it is made to react with this nitrous acid, it forms it gives alcohol, that is ethanol, plus this nitrogen gas is also given out. Now, then you got as far as these are the primary aliphatic amines. Then we have got these primary aromatic amines, like we have aniline. Now, these aromatic amines, they react with this nitrous acid at a very low temperature, that is below 273 Kelvin, that is in ice cooled, to give rise to the formation of diazonium salts. Now, this reaction in which we see there is when there is formation of these, when these diazonium salts are formed by treating these primary aromatic amines with this nitrous acid, that is called as diazotization. Now, you see here, this is aniline. This, when it reacts with this nitrous acid, you can see here, ice cooled at a low temperature 273, it gives rise to the formation of this benzene diazonium chloride, and I have told you that this reaction is called as diazotization reaction. But if the temperature is slightly above than this 273, that means if the temperature is above 278 Kelvin, then these aromatic amines, they also give rise to the formation of these this aromatic alcohol, and that is a phenol, and with the evolution of this nitrogen gas. You can see here, this is aniline. When it is made to react with this nitrous acid at a temperature greater than 278 Kelvin, it gives rise to the formation of this is phenol plus nitrogen gas is given out. Similarly, these secondary aliphatic and aromatic amines, they react with nitrous acid slowly in cooled, that means at a low temperature, to form yellow oily nitrosamines. You can see here, this is secondary amine, dialkyl amine. When it is made to react with this nitrous acid, it gives rise to the formation of, this is called nitrosamine. You can see here, this is a secondary amine, that is diethyl amine. It reacts with this nitrous acid and it forms this nitrosamine, that is called as, this is NN diethyl nitrosamine. So it gives a yellow oily liquid. It forms a yellow oily liquid. Then we have got the tertiary amines. Now, as far as the tertiary amines are concerned, they also dissolve in this cooled this nitrous acid, and to give rise to the formation of salts, and which get decomposed on warming to form nitrosamines, and alcohol is also formed. You can see this is a tertiary amine. It is trialkyl. This is trialkyl, this amine. When it reacts with this with cooled this nitrous acid, it forms this is nitrite salt, you can see here, and which upon warming it forms this nitrosamine, plus alcohol is also formed. Then we have got this, you can see here, this is triethyl amine. Triethyl amine is a tertiary amine. When it reacts with this nitrous acid, it gives rise to the formation of, this is triethyl ammonium nitrite. Then as far as these aromatic tertiary amines are concerned, these aromatic tertiary amines, they react with nitrous acid to give colored substituted nitroso compounds. You can see here this is NN dimethyl aniline. When it is made to react with this nitrous acid, it gives rise to the formation of this is para nitroso anion dimethyl aniline. Then we have got one more reaction, that is coupling reaction. This is again a well-known reaction. In this reaction we see this these aromatic amines, they react with these diazonium salts to form azo compounds, and the reaction takes place in acidic medium, so they form the formation of these azo dyes. You can see here this is benzene and diazonium chloride. When it reacts with this aniline, it gives rise to the formation of this is a para amino azobenzene. It is a yellow dye. You can see first the reaction takes place like this. It gives rise first it forms a diazo amino benzene, which then undergoes rearrangement, and it gives rise to the formation of this para amino azobenzene. It's a yellow dye. Then we have got one more reaction, that's oxidation reaction. Now as far as this oxidation is concerned, these amines, they undergo oxidation in air to form these alkyl amine oxides. You can see here this is ethylamine. When it undergoes this oxidation in air, it gives rise to the formation of this is ethylamine oxide. This is ethylamine oxide, you can see here. Then you have got aniline. As far as aniline is concerned, aniline also gets oxidized in presence of this is sodium dichromate, acidified sodium dichromate. There is sodium dichromate and sulfuric acid, and it gives rise to the formation of p benzoquinone or para benzoquinone. You can see aniline, when it is made to react with this sodium this dichromate acidified, it forms quinone or simply p benzoquinone. So these are the chemical reactions of these amines, which we have discussed in our in today's lecture, and also in our previous lecture. Now in our next lecture we are going to continue with the chemical properties of these aromatic amines, especially the ring substitution reaction in case of these aromatic amines, and we will discuss those ring substitution reactions, electrophilic substitution reactions in these aromatic amines in our next lecture. So this is for today. Thank you very much.